Okay, welcome to another Programming in ARM Assembly video series. And in this video series, I'm trying to make an ASCII to integer conversion function. All right, now let's get back into the code. But before I do that, I want to mention that at the end of the last video, I assembled, linked everything, and ran it. But I actually forgot to put the call to the ASCII to integer function that I had written. I forgot to put that call in main. So when I was doing that test at the end, I wasn't actually testing anything. I was only testing that the prompt worked and that we were taking input from the keyboard, which I had already checked earlier. But after that, it was just dropping straight down to the exit. So one of the first things I want to check is right after we get that input from the keyboard, I want to branch and link to ASCII, and I'm just going to do a quick make and check because I just want to ensure that we don't get a seg fault, and I want to ensure that we don't get stuck in an infinite loop. This was the test that I meant to do, but I just forgot to put in the branch and link call in main. So will it work? Type a number, 456. Okay, so now at least we're calling into ASCII and returning back to main and then exiting out of the program. We didn't get a seg fault, and we did not get stuck in an infinite loop. It doesn't necessarily mean that our function's working like we want. So let's go ahead and check that. There's a couple ideas I have. We'll try both. But first, let's walk through it in the debugger just to see what we can see. So for the debugger, let me list out these lines. And we have multiple files here. So I'm going to set a breakpoint at in main.s, and I'm going to set that breakpoint at, let's see here, where do I want to put that breakpoint? Let me list this out a bit further. Let's set the breakpoint right before we branch and link into ASCII. That way we can step into that. So I'm going to put a breakpoint in the main.s file at line 23. And I found that when I'm working with multiple files, if I don't specify the file name, sometimes it's just ambiguous to GDB, I guess, and it doesn't know which file I'm referring to. So this way, hopefully it will know. Hopefully it will do what I intend. Okay, so we've set that breakpoint. Let's go ahead and run, and let's type in the number 456 because that's what we keep. That's the one I keep using. And now we should be We should be ready to step into the branch and link function. So let me use S to step into, and or not the branch and link function rather, but the ASCII function. Okay, and it looks like that's correct. So let's step through this and follow the logic to make sure everything is doing what we want. So we're going to push those registers onto the stack. We're going to initialize those three registers to 0, 10, and 1. Now we're going to load the first byte off of the pointer or off of the string that we typed in, and we're going to store that byte in register 0. So let's take a look at that. So let's step forward, and now let me look at what that byte value actually is. We can see here it's 34 in a hex, but if I do information R, so information on registers, I can see in R0 that the actual decimal value is 52, and 52 minus 48 is 4. So I know that we have the correct. Number there, so that the integer of that will be 4. So now we're going to do that comparison and say, did we type in a negative sign? We'll step forward, and then now it says, move into register 4, -1, if the result of this came back true. So let's step forward. Register 4 is currently 1. And when we step forward, it should still be 1, and it is. So that instruction correctly did not carry out that operation because the result of this was not true. And now we're going to say do this, subtract from register 1 byte if the result of that was not true. So currently register 1's pointing to that part of memory. And when we run this next step, we should back up by 1 byte. So I guess we'll go from 2101 to 2100. So let's step forward, and we did. We went from 2101 2101 to 2100. 2100. All right, and now we're entering into the main loop where we're going to strip off 1 byte at a time. So let's step through here. So now we have our byte loaded into register 0, and if we remember, 34 is 52 in decimal, and 52 in decimal is actually the integer 4. Now we're going to subtract 48 off of that number, 48 decimal off that number, and we end up with the integer 4. And the integer 4 in hex is the same as it is in decimal. So now we're going to compare that value with the immediate number 0, and we're going to say if this number is less than 0, then branch to the update registers, but that's not 0, so we'll step forward. And now we're saying make register 2, which is currently 0. We're saying set register 2 equal to R3 times R2, which is 10, or A in hex. So 10 times 0 is 0, plus 4 will be 4. So when we step forward, register 2 should have the value of 4, and it does. Now we'll go back to the beginning of the loop, we'll grab the next byte, and then when we get to the end of this loop, the value in register 2 should now be 45. So I can't convert that in my head, but if we do information registers, we can see that register 2 now has the value 45. So let's step quickly through the next iteration, and at the end of this cycle, register 2 should be 456. And it is indeed 456. Okay, so now we'll step back through the loop again, and this time we're going to be encountering the carriage return. So we grab that byte out, which is, I remember is 10 on the ASCII table. I just happen to remember that. So if we look at register 0, we have A, which is 10 in decimal. We subtract 48 off of that, so we end up with this big negative number, or negative 38. And we compare register 0 with 0, and now we're saying if register 0 is less than 0, which it is, then jump down to the update registers label, which we did. And now we're saying set register 2 equal to R4 times R2. R4 is just the positive number 1, and R2 is 456, so it won't really have any effect. But again, if R4 had been updated to a negative number, then we would now be turning the value that we grabbed into a negative number. And then finally, in order for this function to return properly, we want to take whatever number is in R2, move it into R1, and then go back to the calling function. So let's make sure right before we return that we do have 456 in R1, and we do. Now when we pop those registers back off the stack, you can see that register 2 lost that value because it now contains the value that it had before we went into A2I. But since we did not pop R1 off the stack, R1 still contains the value 456. So when we step forward, we should be back into, well, actually, I think we're just at the end of the program, more or less. Yeah, so we're just at the end of the program. So it looks like it's working correctly. We can do a couple things just to test, and we also want to make sure that we test that negative condition. So what I have in mind for this main.s, again, which is just like a driver code in order for us to be able to test this function, what I can do is I can say compare register 1 with the immediate value of 456, and then load into register 1 if equal load, let me think about this. Yeah, load into register 1. If that was true, then load into register 1 success, which we haven't defined yet. And then load into register 1 not equal a message called fail. And then we will branch and link to our print function. So the idea here is we're gonna call the A2I, and then if we type 456 and it did the conversion correctly, then we'll get the success message. If we type something other than 456, or if the conversion failed, then we'll get the fail message. So let's see what we get here. So let's say we have success and we have fail. So let's just change these messages really quick. Success, new line, fail, new line. All right, hopefully I set that up correctly. Now let's write that out. Let's quit out of here. Let's make, figured I messed up something. Undefined reference to fail. Oh, I typoed here. I got fail E. How appropriate that I failed on the fail message. All right, so let's clear this out. Let's make, and let's run this. So if we type 456, that's the value we're comparing, so we should get success. And we do. Now, if we type something else like 234, we should get a fail, and we do. So that tells me that our A to I is working. But I also want to make sure that it works for negative numbers. So let's change this to the immediate value of negative 456. Let's write this out. Let's quit, make our code, run, and we should have, let's try success first. Okay, that's good. And let's try fail. So let's try 456, and we got a fail. All right, so yeah, I feel like this is absolutely working as intended. Let me just take one last quick look at not this one, but A to I. See if there's anything that I want to do. I'm not super crazy about this label name update registers, so maybe I'll change that before giving this function my final blessing, but otherwise it does seem to be working as intended. So that's going to wrap it up for this video series. If you made it all the way to the end, thank you so much for watching, and I'll see you in the next series.